Hai, selamat sejahtera. I am Puan Hanisa here. I want to explain how to answer question involving distance time graph. Okay, this is part of chapter 6 from 5. But before that, I will explain first about the quantity represented by the gradient of the graph. Okay. Okay, this is the distance time graph. You can see why it is distance time graph because the x-axis, the y-axis is the distance and the x-axis is the time. Okay, so this is distance time graph, and we are going to discuss what is the gradient of this straight line. Okay, this graph represent. Okay, so before we start, we revise the formula that you have already learned. Okay, the first one is m. M represent the gradient. Okay, a gradient equals to y2 minus y1 over x2 minus x1. So if you have a straight line, 1 point, 2 point, any point on the graph, one you will label as y2, another one is y1. Okay, what is the y? It is part of the coordinate x, y. Okay, the coordinate is written in terms of x, y, right? So x, y. So any of these you label as x1, y1, x2, y2. Okay, must be paired together. If this is 1, here also 1. If this is 2, here also 2. You cannot write x1, y1, x2, y2. Cannot. Okay, this is how you calculate gradient. And then formula for speed. Speed equal to distance over time. Okay, and average speed is the total distance traveled over total time taken. Okay, now what is the quantity represented by the gradient of the graph? Okay, the gradient of the graph for distance time graph, okay, represented the rate of change. Okay, rate of change, right, of the quantity on vertical axis with respect to the quantity on the horizontal axis. Okay, the quantity on vertical, this is vertical axis and this is horizontal axis. The rate of change of distance over time. Okay, the rate of change of distance over time. Vertical axis over horizontal axis. Okay, now we check. Just now you see that the formula for speed is distance over time, right? And when you calculate gradient of the distance time graph, distance over t, this is actually the formula for speed. Okay, so that's mean the quantity represented by the gradient of the graph is the speed. Okay, so that's mean rate of change of distance with respect to time is actually the speed. Okay. So this is to discuss the formula for gradient, vertical distance over horizontal distance. Okay, this is y2, this is y1. So to calculate the vertical distance is y2 minus y1. Okay, horizontal distance, okay, this is x2, this is x1. So horizontal distance is x2 minus x1. Okay, see? Okay, now calculating the speed from distance time graph. When the gradient of distance time graph calculated, actually you are calculating the speed. What this means? The meaning of this is when you are asked to find the speed of a journey, okay, using the distance time graph, you need to find the gradient of the graph. Why? Because when you calculate the gradient of the distance time graph, you are actually calculating the speed. Okay, so note that gradient of distance time graph is equal to speed. Remember, gradient of distance time graph is equal to speed. Okay, example. Hanif walked from his office to canteen for some refreshment. After finish his drink, he get back to his office to continue his work. The distance time graph can be drawn according to the story. Okay, so distance time graph is actually represent a journey. Okay, when okay, you have the y-axis as the distance and x-axis as the time. Okay, this will represent the journey. When the time increase, when the distance increase, the time also increase. Okay, so Hanif walked from his office to canteen for some refreshment. Okay, let's say that his office is here at 0. Okay, at the origin. When he walks to his office, that means the distance increase, the time also increase. So this straight line. Okay, and then for some refreshment, that's mean he stay there for some times to have drinks or what, and then that's mean he's not moving, right? So when he's not moving, the line of the graph will be horizontal. Okay, even though he's not moving, but the time is increasing. Okay, so like right now you are not going anywhere, but the time is moving. Okay, so the time increase, but the distance is maintained like this. Okay, not moving, stationary position. Okay, after he finishes drink, he get back to his office. You see that the office is at 0 0 just now, right? 0, the distance 0. Okay, distance 0, that's mean he must go back to distance 0, so he goes back here. Okay, so you see there's this decreasing line represent that turning back. Okay, going back. Okay, and when you calculate the gradient, it will be negative value represent the journey of returning back. Okay, so this is the graph according to the story. Let's check. Okay, so here, okay, from here to here, that's mean this distance is the canteen. Okay, this is Hanif office. Okay, from office he goes to the canteen and then stay there for some time and then go back to the office. Okay, next, how to find speed for a period of time from distance time graph. Okay, this is the formula. Okay, repeating formula, so you must remember speed equal to distance over time, average speed equal to total distance traveled over total time taken. Okay, now example, the distance time graph shows the distance covered by a boy from the starting point to another point and back. Okay, so you could see that this is the starting point to another point, and then okay, remember this represent the stationary position. Okay, that means he waits there for some times and then he went back. Okay, from the graph, find the speed for the first 15 seconds. Okay, from the graph, find the speed for first 15 seconds. from the graph, find the speed for first 15 seconds. So the time here is in second, right? So 15 second is here. Find the speed for the first 15 seconds. So speed, remember, speed equal to the gradient of the graph. To calculate the speed, you must calculate the gradient of the graph. And you see there are three lines here. 1, 2, 3. Okay, three straight lines. That means you have three values of gradient. Okay, from this point to this point, there are a value of gradient here to here, a value of gradient here to here, a value of gradient. Okay, so because the question asks about the first 15 seconds, so you take this point and this point. Okay, easier. So this is 0, 0, while this is 15 and 100, right? Okay, so 15, 100. So speed equal to gradient. So calculate gradient. 100 minus 0 over 15 minus 0. So equal to 100 over 15. Okay. So can you see? The gradient is 100 over 15. Okay, let's check the answer. Okay, see? Speed for the first 15 seconds is, okay, see, 100 minus 0, 15 minus 0. Okay, this is actually formula for gradient. Okay, remember, find gradient is finding the speed of distance time graph. Okay, so this is the speed and also gradient, the gradient of the line for the first 15 seconds. Okay, next question, question B. How long did he rest? Okay, so the keyword here is rest. Rest, or we call it not moving, or we call it stationary position. Okay, this means that the time increase but the distance stay. Okay, so let's check the graph. So not moving is from this point to this point. Why? Because the distance not increase or not decrease, right? Okay, so here, how long? From 15 to 30 second. So how long? So this is 30 minus 15 second. Okay, so how long did he rest? 30 second minus 50 second. The answer is 15 second. He takes 15 seconds to rest. Okay, next question. Question C. Find the speed where the boy back to starting point. Okay, you can see the movement when the boy get back to the starting point is represented by this straight line. Okay, because it's going down, right? Okay, so what the question is now, find the speed. Okay, so the speed of distance time graph equal to the gradient of the straight line. So calculate the gradient. This point is, the x is 30. Okay, the x is 30 and the y here is 100. And here the x is 50 while the y is 0. So to calculate the gradient, okay, or we calculate speed equals to 100 minus 0 over 30 minus 50. Okay, so let's check answer. Oh, terbalik. It's okay as long as y2, y1, x2, x1. Okay, you can write as 100 minus 0 over 30 minus 50. Okay, or you can write as 0 minus 100 over 50 minus 30. What you cannot write as 0 minus 100 minus 0 over 50 minus 30. This one cannot, because 100 the partner is, okay, the pair is 30. See, 100 the pair is 30. Okay, so you cannot put it at the back, 100 at the front. Okay, if 100 at the front, 30 also at the front. Okay, 100 at the front, 30 is at the front. When 100 at the back, 30 also must at the back. You cannot write it like this. Okay, this is wrong. Okay, whether this or this. So equals to negative 100 meter per second over 20 second. Okay, the answer is negative 5. Okay, what is the negative sign indicates? The negative signs indicates the direction of the journey is reverse, return journey. So this negative is only to represent the return journey. When you got the answer is negative 5 meter per second, that means the speed is actually 5 meter per second. Negative means going back, okay, or return journey. Okay. Okay, question D. Find the average speed for the whole journey. Okay, remember, formula for average speed. Average speed is total distance over total time taken. Total distance. Okay, from this point to this point, you see that the the distance increase from 0 to 100. That's mean this is 100 meter. The journey from this point to this point is 100. From this point to this point, 100 to 100, not moving, so 0 meter. From this point to this point, okay, going down, the distance is also 100. So the total distance is 100 plus 100 over total time taken. Okay, 0 to 50, including this time. Okay, don't minus the resting time here. Okay, you must include all the time. Total time taken from 0 to 50, so over 50 seconds. Okay, so let's check. 200 over 50, so equal to 4 meter per second. Good. This is how you calculate the average speed. Okay, what next? Okay, summary. Gradient of a graph is the rate of change. Okay, remember the gradient of the graph is also called the rate of change, okay, of the quantity on the vertical axis with respect to the change in the quantity of horizontal axis. Okay, and for distance time speed, the rate of change of distance to time. Gradient of distance time graph represent the speed. Okay, so that's what I actually explained to you. Okay, remember the gradient of distance time graph is the speed of the journey represented by the graph, and you also must remember when you have a distance time graph, when the line is like this, a straight line, okay, this is the uniform speed. Okay, this represent uniform speed because this is a straight line. Okay, when the straight line, okay, change direction, for example like this, okay, that's mean the gradient also change, right? So this is not uniform anymore. The uniform speed is only here and here, but from here to here is not uniform. This is non-uniform speed. And when the graph is horizontal, the line is horizontal like this, okay, this represent the stationary position where the person or is not moving, okay, stay at the place for some time, okay, resting position. Okay. Okay, Now, this is actually SPM formatted question. Okay, example. So let's discuss. Okay, you're given a diagram and sentences that you need to read and understand. Okay, so let's read. The following distance time graph, okay, so this is distance time graph, shows the journey made by Ali and Ah Chong. Okay, so Ali and Ah Chong are moving here. Both of them start from, okay, both of them start from Ah Chong house. So you see that for this graph, it start here, right? So that's mean here, 0 kilometer, okay, 0 kilometer here represent Ah Chong house. Okay, Ah Chong sent Ali to the taxi station. Okay, both of them start here. Okay, to send Ali to taxi station. So that's mean for 20 kilometer here, this is taxi station. And this journey is represented by OA. OA. Okay, OA. BC. Okay, so where is BC? BC represent the journey made by taxi. Okay, so this is the journey of taxi that sent Ali to his office. From here, this is taxi station just now. He went there until C, sent Ali to his office. That means K is actually Ali's office. Okay, BD represent the journey. Okay, BD represent the journey of Ah Chong made from taxi station back to his house. Okay, you see that it goes down to 0 and 0 is Ah Chong house. That means this is Ah Chong. This taxi station take Ali. Okay, this journey for Ah Chong. Okay, Ah Chong to his house. Okay, okay. So understand the sentences. The following distance time graph shows the journey made by Ali and Ah Chong. Both of them start from Ah Chong house. Ah Chong sent Ali to the taxi station, and this journey is represented by OA. BC represents the journey made by the taxi that sent Ali to his office. BD represents the journey Ah Chong made from the taxi station back to his office. His house. Okay, you can read many times as long until you understand the situation. Okay, so question A. Find the distance between taxi station and Ah Chong house. So where is taxi station? Here is taxi station. And where is Ah Chong house? This is Ah Chong house. 0 to 20, right? So for question A, answer is 20 minus 0 equals to 20 kilometer. Okay, so this is answer for question A. Question B. Find the average speed for the entire journey made by Ah Chong. Average speed. Remember, average speed. Average speed. Average speed equals to total distance over total time taken. Okay, remember? So average speed for who? For Ah Chong. Okay, so Ah Chong journey is from this to this, stay here, and then going back to the house. So from here to here is 20 kilometer. B to D is also 20 kilometer. Okay, so equals to 20 plus 20 over, okay, 0 to 30 minute. Okay, 30 minute. Okay, check. Find the average speed for the entire journey by Maya Chong. Okay, so equals to 40 over 30 minutes. So equals to 4/3 kilometer per minute. Okay, because the question didn't ask you to find in any unit. Okay, but what if the question said find the average speed for the entire journey back Mak Ah Chong in kilometer per hour? Okay, so this one I'm using the kilometer per minute. What if the question asks you to find the average speed using kilometer per hour? So I take this from here, 40/30 minute, right? So 30 minute you convert to hour is 30 divided by 60, right? Okay, so divide 60, so equals to 40/0.5, so equals 80 kilometer per hour. Okay, this is the answer in km per hour, this answer in km per minute. Okay, next, C. If the speed of the taxi is 48 kilometer per hour, okay, it talks about the taxi, so the taxi is here. The speed of the taxi is 48 kilometer per hour. Okay, use hour. So if 48 kilometer per hour is the speed, that's mean the, okay, remember speed equal to what? Gradient. Okay, that's mean the gradient of this straight line BC equals to 48. So find the value of K. Okay, let's check. This point C is 35. Okay. The B here is 20. Okay. 20. 20, 20, right? Okay, so gradient, okay, question C, gradient equals to speed. Okay, so speed equals to 48. Speed equals to K minus 20 over, okay, because this is in kilometer per hour, you convert the time into hour. So 35/60 minus 20/60. Okay, this is equal to 48. Speed equal to 48, right? So 48 equals to K minus 20. Okay, calculate the denominator. 35/60 minus 20/60. It's 1/4. Okay, over 1/4. Okay, 48 equals to K minus 20 over 1/4. You're going to find K, that's mean 48 times 1/4 equals to K minus 20. So you multiply, this is equals to 12 equals to K minus 20. So K is equals to 12 plus 20. So K is 12 plus 20 equal to 32. That means the value of K here is 32 kilometer. Okay, that means from Ah Chong house to Ali's office is 32 kilometer. So this is answer for question C. Okay, you just use the formula and the concept, okay, that I explained just now. Okay, next Okay, the next question we discuss one more question. The distance time graph below shows the journey of a lorry and a bus. OMN represent the, okay, this OMN represent the journey of the bus, and then from Sepang to Taiping, whereas A and B, okay, A and B represent the journey of lorry from Taiping to Sepang. Okay, so let's check the diagram. This is distance time graph. You have OMN, OMN. This represent the journey of the bus. Okay, the bus. And you have A and B represent the journey of, okay, this is represent the journey of the lorry. Okay. And it said from Sepang to Taiping and Taiping to Sepang. That's mean the bus from Sepang to Taiping. So that's mean this is Sepang, this is Taiping, right? And the lorry is from Taiping, A, start from here to Sepang. Okay. Question A. The average speed in kilometer per hour for the bus which travelled from Sepang to Taiping. Average speed for the bus. Average speed for the bus. So from here to here, average speed, average speed, average speed equals to total time taken, total distance over total time taken. You must remember this formula, so you can write it many times. Okay, jangan malas. Okay, next, total distance is from here to here. That's mean from here to here, 38 kilometer over total time taken from here to here. It is 4 hours. So equals to 38 over 4, 9.5 kilometer per hour. Okay, this is answer for question A. And then for question B, the value of T if the lorry travel with a uniform speed. The value of T if the lorry travel by a uniform speed. Okay, that's mean, okay, A and B, okay, for lorry is uniform. Speed, that's mean the gradient are same from A to B. Okay, so how to find T? You can divide this into two straight line, AM and B. Okay, ataupun AB AM ataupun MB AB. Okay, so you can use many pair. Okay, because we want to compare the gradient. Okay, that means gradient for AM and gradient for MB are same. So M for AM equals to M for MB. If you don't want to use AM and MB, you can also use M for AB is equals to M for MB. Or you also can use M for AB equals to M for AM. Okay, you can use any pair. Okay, so have M here represent the gradient. Okay, so let's check the gradient for AM. You must find the point. This is 0, 38. This is T, 26. This is 0, 4. 40. B is 40. Okay, so which pair you want to choose? Okay, the answer for B I write here. gradient AM. I use AM and also AM AB. Okay, so gradient for AB. Gradient for AB is 38 minus 0 over 0 minus 4. Okay, equals to gradient AM. Gradient AM is 38 minus 26 over 0 minus t. Okay, so that means this is 38 over negative 4 equals to, okay, 38 minus 26 is 12 over, okay, negative t. Okay, so because both have negative, so we can cancel this negative. So 38 over 4 equals to 12 over t. So we cross 38 t over 12 over 4. 12 times 4. Okay, so t equals to 48 over 38. So equals to 1.26 hour. Okay, so this is the answer. Okay. Okay, so that's all for the example. Okay, we revise here. We make a summary. Okay, in this section, in this video, I discuss about the gradient of speed, distance time graph. Okay, the gradient of the distance time graph is equal to the speed of the journey shown on the graph. And we also discuss about the average speed. Average speed equals to the total distance over total time taken. And you also learn how to read the graph. Okay, this represent the graph, the okay, distance time graph. This represent the uniform speed. Okay, this represent the stationary position, and this represent the reverse direction. Okay, the reverse direction. Okay, so the gradient here negative means it is reverse direction. Okay, the gradient here is positive. Right? Okay, so that's all for this video for today. Thank you. Bye bye.